You're probably here to learn about internationalization, because that's what the talk is going to be about. Internationalization with YUI 3. How many of you work on internationalized applications in some form? Okay, pretty much everybody. Are they typically multilingual applications? Who's working on applications that have that actually support multiple languages in the user interface? Okay, not everybody. So the rest, I assume, works on applications that have only one user interface language, but still have to support multiple languages, say, when it comes to content. Okay. Or you work in languages that just are not English, and therefore you care about internationalization. So it's pretty common. We need internationalization because every language is a minority language. So if you want to reach a large user base, then you have to support multiple languages. But often also we have applications that are monolingual, but in a language other than English. So then you care about internationalization of the platform that you're building on. So that's why YUI has to be internationalized. And then your users may be anywhere on the planet, München, Seoul, you name it. And so you have to think about what does it mean to use application in that context, in that time zone, in that cultural environment. What do the users expect there? And then people use strange characters, and just to support those strange characters, you also have to support internationalization. How many of you have been in previous talks about JavaScript internationalization? Say either mine or the one by Andy Clark? Nobody? Ooh, okay. If you had been there, you would be used to us whining about how bad JavaScript is when it comes to internationalization. So there's very little internationalization functionality in JavaScript itself. So if you look at the ECMAScript standard, you find there's number and date formatting, string comparison, and case folding, and that's it. And then the problem is that you cannot even control the time zone or the language that's used for that functionality. So you probably know that different languages sort strings in different ways. So when you call the string comparison function in JavaScript, the browser will pick some language for you, but it may not be your language. So that's also a problem that makes even the little things that are there even less usable. Another big problem is that in regular expressions, you have basically no Unicode support. You have some character classes, but they all only work for ASCII characters. So there's no way to say, check whether this character is, say, a right to left character, Arabic or Hebrew or other languages that went from right to left. If you want to check that, you have to give the entire list of characters that would match that. And finally, there's very poor support for supplementary characters. How many of you know what supplementary characters are? Okay, I guess I have to explain. So when Unicode started, it was originally designed as a 16-bit character encoding. So 16-bit allowed you to address about 65,000 characters. But then it turned out that if you encode all languages or all scripts in the world, and also go back in history, what people have used in the past, you actually need more than 65,000 characters. So they made an extension mechanism so that you can have up to about a bit over 1 million characters. They did that by setting aside two ranges within the 16-bit range. And said if you have a code unit from the first range followed by a code unit of the second range, then you have a supplementary character. So that allows you to address the other 1 million characters. Now, JavaScript is still mostly based on the original idea of 16-bit units. So it's kind of interesting. In some functions, they allow you to use supplementary characters. But if you look at some functionality that's specified in the ECMAScript standard, they explicitly prohibit you from doing the right thing for supplementary characters. So there are a number of issues here. So in the past, I often said, okay, if it doesn't work on the client, well, do it on the server. Often that was the only answer we could give because there was not much there. Now, if you want to write a real Ajax application, that doesn't really work well because you want to do as much as possible on the client. If your server happens to be in JavaScript itself, as we have been talking about a lot these days, Node.js and so on, then that answer does also not help because you're based on JavaScript. So we really need better internationalization, both in JavaScript as a language and in the JavaScript toolkits like YUI. We skip this one. So what I'm mostly going to talk about is what we did over the last year to improve YUI and help you build better applications using as much as possible from the YUI toolkit itself. So the first thing we also have to talk about is Unicode processing and how to avoid mojibake. Does anybody know the last word here? So it's actually pronounced mojibake, and it stands for change characters. So that means you have some text that the user entered or that you have an application, and it shows up something else on the screen. So you might have, say, Unicode escapes suddenly show up on the screen because something went wrong, or you just get question marks. So a lot of initialization starts with getting the Unicode processing right. So when it comes to character encoding, I'll be generous and say the JavaScript runtime uses UTF-16. So that means it would allow for supplementary characters. It's not always true, but often enough it is true. But then you shouldn't really use UTF-16 over the network because it doesn't go through all protocols unharmed because of null bytes. So on the network, we usually use UTF-8. So you also have to think in two encodings. You should use UTF-8 over the network and probably on disk. But you have to think that at runtime it's UTF-16. To make the conversion work correctly, typically you have to just identify the char set. So when you have a script tag where you load a script that might contain non-ASCII characters, make sure that you specify the character encoding. Or if you send data using ajax calls, make sure that the content type declares the char set. Now we made some changes in YUI over the last year, basically to make UTF-8 the default for most operations. So most importantly, the get utility now by default assumes that you want to load something in UTF-8. So when it creates a script tag, it sets the char set for the script tag. We also modified the build tools so that they can handle UTF-8. So the compressor had to be changed to assume UTF-8 as the default language. There probably are still some corner cases where things don't work correctly. So if you find something doesn't work for UTF-8, let us know. The other thing you often have to worry about is escaping. There are all kinds of protocols that were originally designed for ASCII and then extended. And then they invented their own mechanisms for describing Unicode characters in escape forms. So we have here, anybody read this? It's Yahoo in Korean. And if you want to write that in HTML, where you're not sure that's in UTF-8, you would have to use a numeric character reference. You would see these in HTML and XML. If you want to send the character over using a URL, so in the path or in the query part of a URL, then you would have to use the % encoding. That happens to be supported in JavaScript using the encode URI component function. So that's easy to handle. In JavaScript, oops, you want to go there. In JavaScript source code, you might sometimes use the \u escape sequence. And then if you deal with domain names, you might have to use the internationalized domain name form. So you might see different Unicode escape forms. Generally, you would want to make sure that they're only used in the context where they apply. So you should avoid them as much as possible in other places. When you receive text that might have escapes, make sure you convert them to plain UTF-8 or UTF-16 as soon as possible. And if you need an escape sequence, generate it as late as possible. So now comes the localization. And maybe we should do a little demo. Since nobody has seen this before, it might actually be new to you. Let's make this bigger. So this is the YUI 2 calendar. but actually running within YUI 3. You know that you can use many widgets from YUI 2 and run them within YUI 3 environment. And this is what you usually would get if you just bring up the calendar by itself without specifying any language. So it comes up in English. You see, for example, here, you have the month before the year. You have the days running from Sunday to Saturday. Everything is in English, obviously. If you change the language to something like, let's pick Japanese, things look different. Suddenly you have the year first. You have then the character for year. You have the month and the character for month. You have obviously the localized Japanese names for the days. But otherwise, things run still from Sunday to Saturday. If you go to German, pay attention to the 31 here. This one here. When you switch to German, you see 31 disappears because in Germany, weeks start on Monday, so that the weekend is at the end of the week. That's one change. You also see that the language is now German. If we switch to Thai, you see yet another interesting change. Now the year is 2553, because in Thailand they count years from the birth of Buddha. A similar effect is when you go to Taiwan, where they count years from the beginning of the Republic of China, so from 2012. And the number is, this year is only 99. So there's quite a few variations between the different calendars in different countries and languages. Now, how did I do this? In the past, I would have to basically take the YUI2 calendar and create a configuration for every language separately. There is a way to configure a calendar for different languages. So everything, all the changes I showed here, can be passed in as a configuration. But that's not usually how we do internationalization. What you see in most platforms is something called resource bundles. And now YUI has resource bundles too. So a resource bundle is basically all the data that has to change between different languages, packaged up as a separate file. And then you have multiple files per language. And at runtime, you load the right file that you need. The way it works in YUI is basically that the resource bundles are attached to modules. So you don't have separate names for the resource bundles. They're just a hidden part of a module. The module specifies which languages it supports. And then an application can just request a language or give a priority list of languages that it wants to see. And then YUI can compare which languages a module supports against the requested languages from the application, pick the best one, and then load the resource bundle for that language. So this is what it looks like for a module. This is actually the module that I used to localize the calendar. So I created a little module called calendar localization. And in the module declaration for that module, I say which languages I support. So it was German, English, English for the United States, which is a bit different than maybe the default English, Korean, Japanese, Brazilian, Portuguese, Thai, and Chinese, traditional Chinese for Taiwan. Are you familiar with these identifiers? I see some people nodding, but not everybody. So these are called the BCP 47 language tags. BCP stands for Best Current Practice. So that's a series of RFCs issued by the IETF, the Internet Engineering Task Force. So basically there are two RFCs, 5646 and 4647, that describe these tags and say how they work. What I typically see is a language code, which comes from an ISO standard. Then you might see a script code, which is necessary for some languages that are written in different scripts. So in Chinese, we have traditional Chinese here. The alternative would be simplified Chinese. And then you might use an ISO country code if there are variations between different countries. So once the module has specified which language it supports, it actually has to create the resource bundles. So the way we do it in YUI is basically we have two formats. There's one very simple format called YRB, Yahoo Resource Bundles, and a different one is JSON, basically. So in YRB, you just have a key, an equal sign, and then the actual text you want to have localized. So in this case, I say my short weekdays in Korean are these 7 characters here. And finally, when the module then comes up at runtime, it needs access to the right resource bundle. So there will be magic that makes sure that the right resource bundle is available, and the module can just say, give me my resources here, using the y.intel.get function. And then it can access the parts of that resource bundle just using regular property access. One thing that came up in a conversation I had last week with another YUI engineer is what about accessibility? So we have some components in YUI that basically have to produce a graphical user interface, but then in order to make it accessible for blind people, we also have text hidden behind the graphics so that a screen reader can read to that person what's actually shown on the screen. Now, in that case, the text that would be read to the user was still hard-coded in English. So if you work on accessibility, you have to make sure that even the text that does not show up on the screen, but that the user wants to understand, is localizable and is localized. Blind people don't all speak English. Another issue is that you have to identify the language of the text, because screen readers depend on the language information to set pronunciation. If you have German text and you try to apply English pronunciation to it, it's very hard to understand. Okay, another thing we worked on in YUI 3 is date formatting. I guess many of you know the data type update module, where you can format dates. And again, in the past, you have to provide your own formatting information in order to get different languages. Now, the strings I have here all come from YUI 3.1. I didn't have to provide my Chinese or German translation myself. Well, actually, I did, but other people who use it don't have to. So, data type date is now localized into 53 different language country combinations. This is the thing that Yahoo typically cares about. And the way you use it is just you specify the language you want to use, put it into the configuration for the YUI object with which you start your life, and then in the use statement, you say, I want to use data type date module. And by the time that module is ready, it will know about the localization for the language you've requested. You still have to know the very fundamental formatting patterns that the date module uses, the stir time pattern strings. So you might just say, I want to have the day of the week followed by the day, followed by the time of the day. But then you can just go ahead and format the date. Now, one problem is sometimes you would want to use different time zones. Very interesting could be what is the time zone of the user, or the time zone that you want to use for your site, or the time zone of an event that is describing. And there you run again into the JavaScript limitations. JavaScript only knows the time zone of the browser, which often, but not always, is the time zone of the user. So if you want to say a common time zone for your site, that's hard to do.
What's the difference in time zone of the user and time zone of the browser?
So when you fly from here to some other place in a different time zone, you may not change the setting of your operating system to the new time zone. So you might be in a different location.
Physically,
your
machine
computer still thinks you are here. Good. Another thing that caught the attention of Yahoo recently is bidirectional languages. You may have heard that we bought a company called Maktub last year, I think in September. And since then, there's been a lot of work going on to port our main properties to Arabic. And Arabic runs from right to left. We talk about bidirectional languages because often within the right to left general layout, you might have some pieces that run from left to right. So if you have Arabic text, but you have a number embedded in the Arabic text, numbers are sort of written from left to right. Or if you have an English name embedded in Arabic text, that English name would be written from left to right. In the same way, if you have a user interface layout, Arabic users generally expect the entire layout to be from right to left. But if you have some news coming from a content feed in English, then you would want to display that part again left to right. So that makes things a bit more complicated because you always have to think which direction we're using right now. So the first pieces that made it into at least the YUI gallery are 3 little snippets that Norbert Lindenberg has put together. So the first one basically takes a string and identifies the main direction for that string. That's very important because often you have a text box where the user just enters some text and you don't know yet which language the user is going to use. Or you get a content feed with some user-generated content where you don't know which language the original user has been using. So when it's displayed, you want to identify what is the main direction of the string so you can set the direction attribute correctly for that, because in that case, an HTML element. Then you have a second piece of code that handles that for text entry. So if an input field, it will detect which language is the user entering into that input field and set the direction of that field correctly for the text. And it's also generalized so that you can have a direction attribute on HTML elements or DOM elements and get events when this attribute changes somewhere, so that other parts of the user interface can react to it. For that, I have a tiny demo. So here's an input field, and you see the cursor blinking on the left side. And when I type something in English, it stays on the left side. If I pick my Arabic keyboard here, does anybody just understand Arabic? Okay, I'm in trouble. I don't, so I have no idea what I'm typing now. But what I want to show is that now that I type Arabic, actually the cursor jumps to the right side, and the text comes in from right to left. So that's basically the snippets that was just put in the gallery in action. Good. Back to the presentation.
One question. So this is detecting the language, the keyboard setting on the machine through the browser?
The question is whether it's what the keyboard setting? No, it's actually not. It looks at the characters that are coming in and uses the language of the characters.
Okay.
2 questions.
Yeah, so if you start typing numbers, then will it switch back over?
Let's try. I mean, if I already have another Arabic text, it will actually stay with that direction. See, it actually changed my numbers to Arabic numbers.
My question was a follow-up to that. Now, what if you start typing?
But if I delete everything, if I use an empty field, and I go back to my US keyboard and type in digits. Oops, digits. Only digits. They come from left to right.
But I was talking about the bidirectional. So like if you type some Arabic and then you wanted to do an English name, how does that look?
It basically looks at the first characters in the string. So if you start typing in Arabic, it will be from right to left, no matter how much English text follows.
Okay.
If you start typing in Latin script, say if I type something in ASCII here, then I switch to Arabic, it will say left to right. So it uses the Unicode BIDA algorithm, which looks for the first strong directional character in the text.
So if you start with Arabic and then switch to English, let's say you have an English name in Arabic text, will the English go in from right to left and then become unreadable because it'll be reversed? Or?
That's right. So you type something in Arabic, nobody can read, so you can read. Type something in English, to change my keyboard. So you see it comes in, but now the English text is written left to right.
Oh, okay.
But the overall context stays right to left.
These features are in the browser, right? It's doing this thing, right? I mean, that's not YUI kicking into.
This is actually YUI kicking in.
It is.
So YUI here, or the gallery module, that's not quite part of YUI yet. It detects which characters are being typed, looks at the direction of the characters, and then sets the direction of the text field appropriately. So then the browser recognizes, okay, the input field now has the direction of right to left. And then the browser does the rendering. So it's a combination of both.
What version of the gallery module is this in?
What am I reading here? Quite recent, September 22nd. Good. Sorry, I had to talk about the snowman. Who was in Vango's presentation yesterday? Okay. So he alluded to the fact that there might be some problems with the code that is YUI now for work breaking. So here's a bit more detail. So for work breaking, the Snowman module, formerly named Unicode module, it has a pretty reasonable default for many languages because it follows a Unicode technical report. And basically that provides a default behavior that works for many languages. But there's some languages that have special requirements that this algorithm just cannot handle. So the algorithm is based on character classes. It uses large vector expressions to find the character classes and breaks when the character class is changed. There are also cases, say in Korean, where you have a continuous sequence of characters, now and then, both Korean and Hangul characters. Where the first one is actually the word I. The entire sentence means I live in Chicago. And the second one says that this previous word is the subject of the sentence. So it's a grammatical particle. They're written together, but when you do work rate, Koreans would expect that they are treated as two separate words. And that is something that you cannot do with a simple vector expressions. You would have to know that this is a particle. Because the same character can show up in other situations, it's just part of the word. So if you don't understand the sentence to some extent, you cannot get it right. The other bigger problem is you cannot cover languages without spaces at all. So if you have Chinese or Thai, those are languages that have long continuous sequences of Chinese or Thai characters. The character classes don't change, but they are separate words. And the only way to detect the words is to have very good dictionaries. And you don't want to download dictionaries for Chinese into a YUI application. So if you want to support Thai or Chinese, you will have to boot up to the server.
You mean spaces per se, or just you can have delimiter character, like other languages would have a different...
Yeah, there's some languages that have, I think we were talking about it yesterday. So they don't have spaces, but they have a different set of point.
Yeah, a dot.
A dot, yeah, that separates the parts. So that's good enough. But it has to be something that is a separate character class in Unicode. Now, the other module is accent folding. And there we're still discussing whether it's really a good idea to have it in YUI, because it is, I think it's a bad idea in almost all cases. You might get some useful results for English users sometimes. But if you go to other languages, it will fail in most cases. So here's one example where you actually have diacritics changing the meaning of German words. So these two words are German. Betrügen with the dots means to defraud. Betrügen is the past tense of getan, to behave. So, slightly different meaning. In Turkish, you also have different equivalences here. So in Turkish, you have a series of two different pairs of I characters. There's a dates I and there's a dates I. English speakers would say these two characters belong together and should match. Turkish speakers say, no, these two match and these two match. So these two are not related. There was a story going around a year or two ago where misunderstandings about the dot actually led to some murder. So you have to be careful about this. Another thing is sometimes you have equivalences between different words, different characters, but it's actually a different equivalence than you would get from just stripping the diacritics. So again, in German, a very common name is Müller, and it's sometimes spelled as M-U-E-L-E-R, especially if you have used an old typewriter that doesn't have the diacritics. But M-U-L-E-R, something that's a bit separate. It's not the same. And so if you match Müller with the dots to Müller, people scratch their heads saying, what are you doing here? And the same goes to many other languages. So this is the behavior that you should send off to the server. On the server side, we often have good systems that can define equivalences between strings, especially in search engines, and work proper with behavior. And I think that's all I have prepared to talk about.